Hello everyone, my name is Sneha. I am a student of BSc Chemistry Honours 5th semester. Today I will give presentation on the topic Silicones and Phosphazenes from Inorganic Chemistry. Silicones and phosphazenes are examples of inorganic polymers. Inorganic elements can have different valencies than carbon and therefore different number of side groups may be attached to a skeletal atom. This will affect the flexibility of polymers, their ability to react with chemical reagents and interactions with other polymers. Among inorganic polymers, silicones and phosphazenes are two important class of polymers. Now we will discuss about silicones. Silicones are polymeric organosilicon derivative containing SiO-Si linkages. They contain alternate silicon and oxygen atoms in which the silicon atoms are joined to organic groups. These are also called polysiloxanes. These have the general formula ROR, R SiO, R and whole n units. This n represent that we have n number of unit of this particular chemical unit. These may be linear, cyclic or cross-linked. They have high thermal stability. Now the factors affecting the nature of silicon polymers. The nature of alkyl and aryl groups. The distribution of organic groups. The type and proportion of structural units. The extent of cross-linking and the chain length. Now we will discuss about the properties of silicones. Their thermal stability. So if we talk about the thermal stability of silicones, silicon polymers are highly stable toward heat. That is, they exhibit thermal stability up to 200 to 300 degrees Celsius and they have low glass transition temperature. If we talk about the chemical stability of silicones, then the silicones are stable towards the chemical reaction of electron deficient salts. The siloxanes bond in silicones may be cleaved by Grignard reagent, by alkyl lithium and lithium aluminium hydrides. Some other properties of silicones. They are water repellents, they are good insulators, they have non-stick and anti-foaming properties, they are resistant to oxidation. Now the uses of silicon polymers are, they are used for high temperature oil baths, high vacuum pumps, they are used as grease varnishes and these can be used even at very low temperature. Their toxicity is low and therefore these are used in medicinal and cosmetic implants. They are used as grease varnishes and these can be used even at very low temperatures. Now we will talk about silicon fluids or oils. The silicon fluids are usually linear polysiloxanes of 50 to 200 units having low molecular weight. They make up about 60% of the silicones used. If they are prepared by the hydrolysis of a mixture of CH3 whole twice SiCl2 and CH3 whole 3 SiCl, then the chain lengths may vary considerably. Commercially, these are prepared by treating a mixture of tetrakis cyclodimethyl cyclosiloxane and hexamethyl disiloxane with a small quantity of 100% of H2SO4. Uses of silicon fluids or oils. Silicon oils or fluids are used as water repellents for treating building and fabrics. Silicone oils are used as heat transfer media in heating belts. Because of low surface tensions, silicone oils can be used as anti-foaming agents. Their complete inertness and non-toxicity allow them to be used in cooking oils. Silicon elastomers, that is rubbers. The silicon rubbers make up about 30% of silicons produced. These are highly useful because they retain their elasticity from -100 to plus 250 degrees Celsius, which is wider range than for natural rubber. These elastomers may be vulcanized to get rubber. Vulcanization is a process in which bonds are formed between different chains by cross-linking reactions. Types of elastomers. Room temperature vulcanized elastomers, that is RTV. Liquid rubber, LR. High temperature vulcanizing elastomers, abbreviated as HTB, also called heat curing elastomers, that is HCE. Now we will talk about the uses of silicon elastomers. The room temperature silicons have good adhesive properties. These are also used as sealants for sealing. Liquid rubbers were developed particularly for quick, automated and cheap production of small objects in a high number of pieces by injecting molding. HTV silicon rubbers are finding wide applications as transparent tubing in food. Now we will talk about silicon resins. Silicon resins are solvent solutions of branched chain siloxanes containing residual hydroxyl groups. Silicon resins are made by dissolving a mixture of phenyl substituted trichloride chlorosilane, that is PHSiCl3, and dichlorosilane and toluene and hydrolysis with water. Uses of silicon resins. Used as insulating material, mixed with glass fibers for additional strength. It is used as laminates for printed circuit boards. It is also used for encapsulation of components such as resistors. It is used for non-stick coating for domestic cooking ware. Now we will talk about polysiloxane copolymers. Polysiloxane copolymers are obtained by combining polysiloxane structure with organic polymer structure. These are basically of two types: block copolymer, Kraft copolymer. Now we will talk about firstly block copolymers, in which shorter or longer siloxanes are connected by blocks of organic polymers. Next is Kraft polymers, in which there are continuous polysiloxane chains which are either connected or substituted by organic polymers blocks. Polyphosphazenes, inorganic polymers containing alternate phosphorus and nitrogen atoms with two substituent on each phosphorus atom, as shown in this diagram. Now first of all we will consider the preparation of phosphazenes. First method for the preparation of phosphazene is polyphosphazene is NPCl5 plus NH4Cl gives PnCl2 whole N, that is phosphonitrile chloride, plus 4N molecules of HCl. The second method is the reaction of P3N5 whole N plus N molecules of chlorine gives PnCl2 whole N plus other products. The third reaction for the preparation of polyphosphazene is SnN4 plus SOCl2 plus PCl3 gives PnCl2 whole thrice plus side products. PCl5 on reacting with ammonia gives PnCl2 whole 3 plus HCl as side product. PnCl2 whole 3 plus KSO2F gives PnF2 whole thrice and KCl and SO2 gas as side products. And the next is PnCl2 whole thrice plus PbF2 gives PnFCl whole 4 plus PbCl2 plus other side products. Now we will talk about the other methods of other polyphosphazene. The other type was obtained from trimer hexachlorocyclo triphosphazene by general scheme summarized in figure. The trimer is obtained by reaction of PCl5 and ammonium chloride in an organic solvent, which is chlorobenzene. Polymerization of organometallic substituted cyclic phosphazene. In this method, organic substituents are introduced at the cyclic trimer phosphazene followed by ring opening polymerization of the substituted cyclic trimer to a high polymer. Properties and structures: cyclic phosphonitrile halides, that is NpCl2 whole thrice and NpCl2 whole 4 have been studied. Physical properties: on heating, NpCl2 whole 3 and NpCl2 whole 4 polymerize to elastic product of high molecular weight, and on heating the product gets depolymerized. Substitution reactions: the chlorine atom in phosphonitrile chloride is very reactive and it can be easily replaced by monovalent groups like F, fluorine, bromine, hydroxyl group OH, OR, SH, SR, SCN, NH2, NR, etc. Hydrolysis: the trimer can be hydrolyzed to trimetaphosphomic acid, which undergoes isomeric change to trimethyamido phosphoric acid. Reaction with ammonia: NOCl2 whole thrice reacts with ammonia to give various substituted products by replacing chlorine. However, in presence of excess ammonia, P3N5 formed. Uses of phosphazenes: the phosphonitrile halides are used as rigid plastic fibers because they are waterproof and fireproof and are unaffected by oil and petrol. They are used as catalysts in manufacture of silicons. Thin films of polyaminophosphazenes are used to cover severe burns because they prevent the loss of body fluids and keep germs out.